Hello guys, welcome back to the Finance Frontier. So today we are going to check on solving a linear programming problem using the simplex method. So for example, let's say this is our problem. We have maximization 80x plus 160y plus 120z subject to 2x 4y 1z. You can see this. So first of all, for example, if you're given a statement, you just have to note down the LPP equation, and then next you have to look for the standard linear programming problem. This is like changing these first equations to become a standard linear programming problem. This is by introducing the slack variable. So for example, if this one is less than the inequality is less than, you add a slack variable. But if it is greater than, you subtract the surplus. So let's go to the standard linear programming problem. So you say 2x plus 4y plus 1z. Because it's less than, you say plus s1, which means slack 1, is equals to 300. And then you go to 1x plus 1y plus 1z plus slack 2. Because it is also a less than, you get 200. And then you go to 1x plus 2y plus 3z plus s3 is equals to 240. And then we also have to change the maximization equation for it to become also a standard linear programming problem. So we bring all these values, the values that are on this side, we bring them to the other side. So it becomes negative 80x minus 160y minus 120z plus this p is equals to 0. And then you also have to list x, y, z, s1, s2, s3. All of them are greater than 0. So that is the first step in solving in a simplex method. Then next you go to the actual tables where you have to solve the problem using the simplex tables. So the number of tables is determined by the type of the problem. But for example, if this one was a minimizing problem, you just have to change it to become a maximization problem. Okay, so we start over by drawing our first table. These are the basic variables. How do you know the values that will come here? You just take the last variables on adding a slack variable and changing them to a SLPP. So you take S1, S2, S3, and P. They become your basic variables. And then you just take the equation as it is. You write X, Y, Z, S1, S2, S3. And then the P, of course. And then this is the base or the total. You see these 300, 200, and 240 comes there. So you just take the equations that you formed here at SLPP, and then you feed those values in this table as they are. And then you start by solving the first table. You look for the most negative here on P, and you get that is negative 160. So you have gotten the pivot column. This is the pivot column. It provides the incoming variable. And then we have to look for the pivot row. To get the pivot row, you take this base here, and then you divide by the pivot column to get the ratios. And once you get the ratio, you take the least positive ratio, which in our case is 75. And this gives you the pivot row. And then when you combine the pivot row and the pivot column, you get the pivot itself. And now this provides the outgoing variable. So in our next table, the incoming variable is going to replace the outgoing variable. Okay? Yeah, then we go to, because there are still negatives here, we go to the second table. We are supposed to ensure that there is no negative on the maximization P. Okay, so here you just note down, you bring in the incoming, you bring out the outgoing, and then you bring S2 and S3. Then you just do like we enlisted earlier. But now when it comes to getting these values, you have to to solve them slowly. This means, okay, for you to get the pivot should be 1 in the second table. It should be 1, and anything below or above the pivot should be 0. So we have to make this 1 by subtracting all through by the pivot itself. And then the ones that are below it, we have to make use of the pivot for us to get the values that we are going to use down there. Okay? This means, for example, that we are changing this one to become 1, the pivot. So it is 4 divided by 4, you get 1. So you have to divide all through by 4. So 2 divided by 4, you get 0.5. 1 divided by 4, 0.25. You divide it all through and you get the first row 1 prime. Then for you to get row 2 prime, remember we said everything that is below the pivot should be 0. So we have to form an equation that will make this number a 0. So this can become row 2 prime. No, this becomes row 2, 1 minus 1 into row 1 prime, which is 1. For example, let's say, let me do an example here. We have row 2 prime minus 1 into row 1, no, row 1 prime. Sorry for that. It is row 1 minus 1 into row 1 prime. Row 2 minus 1 into row 1 prime. Okay? So when you have this, just check it out like this. You have 1 here, which is your row 2. Then minus, you have 1, then minus 1 into row 1 prime. Our row 1 prime, the current one is 1. You see? When you do like that, you get is equals to 0. So you just have to find a way that you're going to use the current pivot row for you to make these ones 0. And then you continue like that, drawing those tables until you get to the last table. And when you ensure that everything down here is 0, then you have reached the optimum solution. Then for you to get the values, you have y is equals to 66. S2, we are not using it, which is the slack variable. Z is equals to 36. Then our P, our maximization is equals to 14,880. Okay? And so, because we do not have x, it is not among the basic variables, we have to give our x a 0. Okay? Yeah, so I felt like this was necessary, especially for the finance students. If you have any question concerning the simplex method or any linear programming problem, I am going to point my number. Kindly reach out maybe through WhatsApp, and I am going to be sure to help you to solve it through. It is an easy process that you can go through only if you play around with the numbers well. Okay, thank you for watching. Remember to subscribe and maybe share to other finance students for them to understand better. Thank you.